Friends, the final speaker in this session will be Dr. Sreeman, and he will be making presentation on his research on trait integration to evolve rice cultivars suitable for water-saving aerobic cultivation. Meanwhile, you can put your cards in order so that you can put questions to the different speakers. Dr. Sreeman, please.
Thanks. Thank you. Thank you, Mr. Chairman, and thanks for the intro for giving this opportunity for talking about this work. Basically, what we're looking at this mechanism to now introgress the traits that we look for in terms of the drought adaptation, so that we can make this rice cultivars to be capable of growing under the water-saving rain, the upland kind of aerobic situations. Now, what we did was to now look at the traits that are necessary, and after we identified the traits which we've been talking about in terms of the water use efficiency, and the cellular level tolerance that we look at, we developed elaborate facilities to now phenotype them, and a large number of germplasm was screened for these traits, and the contrasts have been identified, and the donor lines have also been identified. And what we wanted to do was to see if there is a proof of concept can be developed by crossing one another in terms of introgressing the traits into one individual genotype. So what we did was to take a efficient genotype and cross it with a genotype which has better root system, and then we developed the recombinant inbred lines, looked for yield, and identified the individuals which had better in terms of growth and productivity under aerobic conditions. And we identified some of these genotypes, and I'm extremely happy that this particular genotype that we identified here, which is called the KMP 175, which is named as Daksha, which has been released for farmers cultivation under aerobic condition. It gives a productivity of about 5 tons under aerobic condition, which is actually saving quite a bit of water in terms of about 45 to 50%. And basically what we did further was to now find out if we can enhance the productivity in terms of looking into more traits from more distinct other parents into a elite cultivar like IR64, which is generally cultivated under puddled conditions. What we initially did was to have a panel of indica lines of 175 accessions, and we phenotyped it for the traits that we know, and then we genotyped it with SSR markers, a large number of them, and then we identified the QTL by association genetics, and these QTLs are being validated, and we have some of the lines which are used as the donor lines, and the QTLs we know for the traits that we look for, and we identified 2 very interesting genotypes, and we elaborately developed a backcross marker-assisted breeding program in terms of trait introgression into IR64. What we did was to cross the root donor line into IR64 and the water use efficiency donor line into IR64. We combined the 2 F1s, and then at each stage, we used markers for both background and foreground selection so that we reconstruct the recurrent parent as well as to know introgress the donor QTLs into the IR64, and we backcrossed, and then we have right now the BC3F5 genotypes. And these genotypes, we found that the one that we have on the 73, 17, and the number that we have that side are the one which we call the trait introgressed lines, and they have much better roots, and they have much better water use efficiency under the aerobic conditions in the field. And then we have the yield trials as well. A large number of lines were developed, and then from there we identified the ones which are very, very interesting in terms of, the root and the productivity in the field. And what we did was to now go through a whole lot of physiological analysis with the trait introgressed line that we identified, and we could see that these genotypes under aerobic conditions had much better photosynthetic carbon gain, and they had much better stomatal conductance, and they also had better water use efficiency under water limited conditions. And this led to a situation where we could summarize and find out that these genotypes had about 40 to 45% increase in productivity than IR64 under aerobic conditions. And if you were to now grow these lines, we could save so much of water. And then what is interesting to me was to look at the trait introgression in these genotypes. We could see that, this is the laser point, and we could see that there is a 45% better improvement in water use efficiency as we found out by the carbon isotope discrimination. And then we have, because of the better root system that they have, these trait introgressed lines could manage to have better spikelet fertility that resulted in better yield of these genotypes. And what we did was to use a very large number of markers for reconstructing the background of IR64, and right now that what we have is about 97% of the background of IR64 has been reconstructed into this. And you can see here, the IR64, the grain type has been restored, but the kind of phenophysiology that they have improved has tremendous implication in terms of increasing productivity under water limited conditions. And this is perhaps one of those examples where we believe that the trait-based breeding, or the so-called physiological breeding that is coming up now for improving these traits, has shown that the stable isotopes, along with the other kind of measurement that we do in terms of the measuring root systems and the cellular level tolerance, comes handy. And then these will have better drought adaptation, and therefore perhaps can help in terms of saving water for us, at the same time sustaining rice productivity. And one of the major things that we believe is rice eaters that we are, about 90% of the rice is eaten in India, should be reduced in terms of our water footprint. And this is therefore an example of a physiological breeding that we have. And what I want to say is that this is the first time that we did where the graduate students and the faculty from physiology as well as genetics in our institute worked hand in hand, very close, and then we were responsible for developing this. And then I should thank definitely the financial support from the Indian Council of Agricultural Research, the Department of Biotechnology, and the Department of Science and Technology. And thanks to Interdrought for giving me this opportunity. Thank you.